I try to imagine a fellow smarter than myself, and then I try to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. My name is Jesse Lawler. I am your host, and this is the 117th episode of this podcast dedicated to the ongoing improvement of your own brain by any and all means at your disposal. I'm going to be speaking this week with an author by the name of Cara Platoni, who's just come out with a book called We Have the Technology, which is on everything from Amazon to physical bookshelves now. And it's all about the various ways that people are starting to mess with human perception through technological implants, gadgetry, wearables, some of the people at the leading edge or the bleeding edge of those technologies, what the next generation might look like, some of the ethical issues, and just plain head-scratching issues as humans have more and more options beyond just what our genetics and epigenetics give to us as standard issue. She's done a ton of research for this book. I've read about 2/3 of the book at this point, and she's a lively conversationalist as well, so I think you'll enjoy this interview. If you hang around until the very end of the episode, I'm going to zoom in on one of the coolest breakthrough technologies. This is actually like 3 different new technologies being cross-multiplied together, so it's hard to know which aspect of it is actually most impressive, but let's just say that this is a potential human modification technology that would have seemed like pure fantasy 10 years ago, but now there is apparently a working proof of concept. That'll be in the ruthless listener retention gimmick, but as usual, let's kick things off with This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So one thing that I've been noticing as I've been doing the podcast is that this is going to sound weird. This is going to sound worse than I mean it to, but it's been really kind of slowly eroding my sense of self, or at least what I've traditionally thought about a self as being. Because it seems like every couple of weeks there's something that we look at that kind of nibbles at the default definition of what a person is and makes the edges a little bit fuzzier. So, in the past couple of years, there's been a lot of talk about the microbiome, all the non-human organisms, mostly bacteria that live in our gut and have a giant interplay with our digestive physiology, but also our immune system, our neurotransmitters, and how I think they say that by count now, the number of cells within our body that are actually bacterial cells rather than human cells, we, the human cells, are completely outnumbered by our bacterial passengers, and that's weird. We've had other episodes where we've talked about things like the extended mind hypothesis, and to what extent are the devices we use sort of integrated into our personhood, how our memories are these malleable things that really aren't fixed representations of the past, but change a little bit every time that we pull one out of the databanks, re-experience it, and then save it again for later. And so our autobiographical memory isn't nearly as accurate as we like to think it is. And so all these things, none of them are terrible, but they've all been just sort of like whittling away at sort of my cartoon definition of what a person is. And now here's another one. There's an article in Scientific American that's talking about something called Microchimerism. So a chimera is, I think this is like an ancient Greek myth, but it's an animal that has like the body of a lion, and I think the head of a lion, but also the head of a goat, and some scary bat's wings, and a tail of a scorpion, and a bunch of different animal parts. But in biology, when you hear about something that's called a chimera, that is basically one organism that has some body parts, appendages from different things glommed together. So technically somebody that's had like a kidney transplant, I believe that would be considered a chimera. Certainly if you got like a heart transplant from a pig, that would be a chimera. But microchimerism is when you have just a very small number of cells, not something like a full organ or a big swath of tissue, but it's the persistent presence. So these things can't be like dying off and being killed by your immune system. The persistent presence of some genetically distinct cells that live within an organism. So if over the course of the last couple of years you've been reading about microbiomes and you've finally gotten comfortable with the idea that, okay, we have these symbiotic organisms that live inside of us. Not all microbes make us sick, but now we've got something new and weird to contend with, because not only do we have bacterial passengers, it is also not at all infrequent for us to have human cells from other humans other than ourselves that live inside of us in little microchimeric clusters. This is particularly common for women who are mothers, that they have some hanger-on cells from their babies who they've carried in their womb, and somehow or another, this is not very well understood, but the baby's cells are sometimes found within various tissues of the mom, long after the baby's been born. This is like something that can be found like decades later. Researchers will find a male cell inside of a woman and think, well, what the heck is this male cell doing living there? And and it seems like the most likely explanation, is that through some as yet unknown means, these cells stowed away in the mother's body while the baby was gestating. Now, a new study has shown that not only are these microchimeric human cells often found circulating in the blood, they're also embedded in the brain. They found these cells in more than 60% of the brains that they examined in a recent study, and in multiple brain regions. Now, the researchers speculated that because Alzheimer's is more common in women who have had multiple pregnancies, that they might find more of these stowaway fetal cells in women that had had multiple children, and that maybe these stowaway cells were somehow contributing to Alzheimer's. But in fact, they found the opposite. So this is good news for those of us that don't want to think that we're doing anything inadvertently nasty to our moms. The brains of the women who did have Alzheimer's, in fact, had fewer fetal-derived cells. The reasons for this are unclear. There's a whole lot that's unclear as far as these microchimeric cell clusters. It's not known if it serves really any purpose to have them there, whether they're vestigial leftovers or whether there might actually be some adaptive reason for keeping these cells around in small numbers. But it sure is interesting, and it's just one more soft, increasingly fuzzy edge between one person and another.
Smart Drug Smarts, the podcast where smart people talk about smart drugs.
So it has been a busy week in Smart Drug Smarts land since last week in the psilocybin episode. A lot of people reached out in the wake of that, got some emails, got some comments on the website. That was number 116 if you're curious and want to look back at that one. Some people pointing out, at least anecdotally, that psilocybin has been helpful for them with the relief of migraine headaches. So since just about nobody in the entire world likes migraine headaches, might be one more thing worth looking at psilocybin for. Picked up a 5-star review over on iTunes from Andrew Wellis92, who said, "I was referred to this podcast by the guys over at Mind Pump. I gave it a listen and have not been able to stop. Great job." Thank you very much. And thank you also to all of you who filled out a little questionnaire that we had. We put a link to that in the last couple of newsletter editions. For those of you that are recipients of the Smart Drug Smarts newsletter, super, super helpful to get that feedback from you guys on what's working for you and what you're interested in getting more of. We certainly aim to please. We aim to please ourselves too, but luckily we seem to be in pretty good alignment. I think the stuff that we're finding interesting on our end seems like there's a lot of interest in, so hopefully keep that going for a long time to come. If you have not joined up for the Smart Drug Smarts newsletter yet, you can quite easily sign up for that over at smartdrugsmarts.com/newsletter. And we would love to have you. We'll send something out about once a week, remind you if you might have missed an episode, and also sprinkle some links of the kind of stuff that we've been reading around the web. Neuroscience, biology, future tech, and sometimes just some general weirdness. I'm a big believer in looking under lots of different rocks to try to find the interesting creepy crawlies, and sometimes that leads to some of the more oddball episodes. Sometimes it might just lead to an interesting link that's hiding in the bottom of that email. So check that out if you like any reading material. smartdrugsmarts.com/newsletter. Somebody asked me earlier today what my favorite smart drug is, and they wouldn't let me hem and haw. I tried to hem and haw and be like, well, I try to take different things on different days so I don't burn myself out on anything. But he wasn't having none of that, and he tried to really pin me down, and I had to think about it. Ultimately, I wound up going with sulbutamine, and I immediately started second-guessing myself because sulbutamine does have some weird things about it because it's basically a hyperdose of B vitamins. It's this double-bonded synthetic vitamin B1. It can kind of make your pee smell funny. I guess this doesn't happen for everybody, but if you're one of the people that when you metabolize asparagus, it makes your pee smell funny, well, sulbutamine is going to do the same thing to you. But I'm willing to have funny smelling pee, and I really like sulbutamine, and that is one of the compounds at the heart of our mitochondrial stack called mitogen that we've got over at axonlabs.io. Axon Labs is our retail shingle over here at Smart Drug Smarts. Very much appreciate those of you who have checked that out so far, and of course have been really, really happy to hear about the good results that people have had with those couple of stacks. So if you were looking to build out your medicine cabinet, or perhaps consolidate your medicine cabinet a little bit by combining a lot of good things in a couple of capsules, pay a visit over to axonlabs.io and see what we got going on.
Smart Drug Smarts.
So I'm about to be speaking with Cara Platoni. She is a San Francisco Bay Area-based journalist who writes about science topics and is a self-described fan of anything geeky or futuristic. And certainly her book, We Have the Technology, straddles all three of those interests: science, geekiness, and futurism. It's relatively hot off the presses. The book was just published in December of 2015 and is available in all the places that one might find books. It came across my radar screen a couple of weeks ago, and a biostatistician friend of mine said, hey, here's a book that's looking beyond just biometric monitoring and instead going into the dark and weird corners of human body modification for everything from health and medical purposes to good old-fashioned mad scientist can-do enthusiasm. So we reached out, got in touch, and what you're about to hear is just sort of a general exploration of the types of topics that Cara Platoni is covering in her book, and also a little bit of background about how the book got written, which is an interesting story unto itself. So with no further ado, author Cara Platoni.
So I've been a science reporter in the Bay Area for almost 2 decades now, and the Bay Area is just a great place for people who are studying the brain. That kept coming up over and over in my work, and of course, the Bay Area is a great place for gadgets. So when I started thinking about a book, I sort of thought, can I put these two things together? This seems to be sort of where the study of the brain and the body are heading, is this idea of what can we wear, what might we implant that would affect perception. So I got really excited about that. That said, so I interviewed more than 100 people for this book, and only 6 of them were people I had met before on my travels. I had a huge learning curve. I'm not a cognitive scientist. I don't come from a psych background. I had a lot to learn, and I literally kind of went out on the road to have an adventure too. The way I reported this book was I took a year off from my job, and I did a lot of reading to see where different labs, military bases, biohackers, people were doing cool experiments. Once I had found somebody who would agree to host me on their campus or in their lab or at their base, then I would post on Facebook and just say, hey friends, do you know anyone in Colorado? Do you know anyone in Arizona? Do you know anyone who could put me up in London? And people did. So I went through 4 countries and 8 US states, basically sofa surfing, to write this book.
That's great. What were the 4 countries?
So, well, US, I think that has to count, right? Even though it's my home country. Canada, I went to Toronto and Montreal. And then I went to England. I had a few things that take place in London, and then Paris, France.
Interesting. Yeah, I was wondering if Japan was going to be on that list, just because Japanese always seem to be so techno-positive.
I would have loved to have gone to Asia. In fact, there is an important part of the book that is about a program that's happening in Singapore. And unfortunately, I didn't get to go see it in action myself. Some of these things that have to do with health, you have to get into a hospital or into a clinical trial. And there are so many restrictions on that. It just didn't work out in this case. So I didn't get to go, but maybe next time.
So now that you have sort of an overall view of what's going on in like personal modification, I'm wondering where you see this technology getting pushed forward the most. Is it to help people with disabilities or people that have had accidents, or helping with things like athletics or people that are just aggressively trying to press the boundaries of what Homo sapiens are capable of?
Well, I think in my travels, people fell into one of 2 big camps. So one big camp was kind of the academic, university researchers, for-profit institutions, and those guys are working almost exclusively on medically assistive technologies. So these are things like retinal implants to help people with vision impairments. This is neuroprosthetics to help people who might need a thought-controlled limb, who might need a brain-machine interface that enables them to drive a cursor on a computer. And then the other arm of this kind of field of endeavor was biohackers who are doing things for the sake of curiosity, for exploration, not because of a medical need. And maybe kind of in that camp is people who are doing it for entertainment and gaming. So most of those people are working on things that you take off, wearable devices, VR and augmented reality devices that you can take off at the end of the game or at the end of the day or at the end of the movie.
Yeah.
So they were kind of split, I think, into those 2 groups.
That's interesting. Some of these, I guess, have some real ethical implications to them. Some people feel like, that's not natural, that's not human. Did you see anything that made you personally squeamish, that like, that seems like it's going too far? Or did you feel comfortable with everything that you saw that people are experimenting into?
That's so interesting. Well, I would have to say I have been wrestling, even though the book is done, I'm still wrestling with this idea of what is a cyborg, right? Like, where is the cutoff point between what's natural for us and what's medicine and what might be going too far or making some kind of changes or becoming this man-machine hybrid?
Right.
And I can't put my finger on it, because the more I think about it, the more I realize how much assistive technology is already either incorporated into my body or something I use every day and it doesn't faze me at all. So, when you ask people who are really into body hacking this question, they usually say, look, people wear eyeglasses, people wear pacemakers, the cochlear implant has been around for a long time. Nobody freaks out about these things. Some people will take it further and say, look, if you wear clothing, if you wear a watch, all of these things augment the naked body. They give you abilities you don't have. I started thinking about things like, well, I've been vaccinated. I don't get measles because I have this body augment, right? And nobody notices it because it doesn't light up. It's not a wearable gadget, but it's changed my immune system, and that's pretty significant. I started thinking about things like, I've had cavities filled. Well, if you saw me smile, you wouldn't notice anything, but I have this body augment that prevents my teeth from decaying, and that's pretty amazing. So the cutoff line between what is medicine and what is this new cyborg future, I don't know where it is. I didn't see anything that made me too uncomfortable because unlike a lot of the big arguments that come up when you talk about changing the body through genetic engineering, there's no chance that what somebody does to their body today is going to affect their children. So if I put an implant into my body, it's not going to affect my kids. It's not going to affect the germline. It's not a genetic change that alters humanity. It's like a one-time deal, right?
But that's not even necessarily true, though, because there are some things like the Dutch hunger winter during World War II where their mothers weren't getting as much food when they were in utero. And for something like 2 generations now, those people have put on weight more easily. They've tended towards obesity because there was this signal, like, not a genetic alteration, but just not as much food being available when they were in fetal development that was signaling that they were going to be born into a world that was light on food.
Yeah, you're talking about epigenetics, right?
Yeah.
That your environment changes how your genes express yourself. That said, I'm not sure that that's really like a voluntary change. I don't think people are starving themselves, or I don't know, maybe they're trying to eat more healthy when they're pregnant. Do you consider that body hacking? I don't know. What do you think?
I think, like you said, it's very much a sliding scale. People don't consider things like wearing makeup or wearing deodorant to be body hacking, but in a low-tech sense, it really is.
Yeah, that is. And, people would talk to me and say, look, we've had certain voluntary surgeries that are really well accepted now. People get cosmetic surgery, and that doesn't seem like a big deal anymore.
Right.
So, yeah, I'm with you on the sliding scale, I think.
Well, I guess, first of all, let's talk about some of the things that the grinders are doing. For people that aren't familiar with the term grinders, can you break apart what that means a little bit and what some of these people are into?
Yeah, sure. So I bet a ton of your listeners are familiar with the idea of body hacking and know that there are various permutations of it out there in the world. So some people are kind of into optimizing body performance with diet, with nutritional supplements. Some people are really into kind of tracking metrics and optimization with gadgets, smart watches, smart wristbands, that sort of thing. The grinders, they're this kind of what I think of as the electrical engineering arm of the biohacker world. These are people who are actually building gadgets to put in their body, not necessarily on their body, but in their body.
Right.
And the guys that I met were mostly from a group called Grindhouse Wetware. They're out in Pennsylvania. They took their name from the Warren Ellis Dr. Sleepless graphic novels, which kind of portray this sort of semi-apocalyptic post-punk future where all of these people build their own body hacks because they're just kind of sick of the fact that, no one's going to build it for them. They're disappointed. The future hasn't turned out to be as cool as they thought it would. And they've made all these things. Like if you read episode 1, starts out with this idea of an implant that goes in the palm of your hand and you can feel your boyfriend or your girlfriend's heartbeat in the palm of your hand, right?
Huh.
Which I think sounded like a far out idea in 2007 when this came out initially. But Apple Watch came out last year, had the same feature. You can feel somebody else's heartbeat on your wrist.
Wow.
Yeah, so the Grindhouse guys, they're kind of driven by the sense of curiosity and the sense of frustration. Like the human body doesn't do all the things that they wish it would do. I was asking one of them, what motivates you? And he says, well, this sounds kind of sappy, but I wonder what it would be like to see a sunset in infrared and ultraviolet, which are outside of what the human eye can see. And another guy said, I want to pick up radio waves. They were saying there's all this information in the universe that humans can't pick up, but some other animals can, like sharks can sense electricity. And lots of animals can sense magnetic fields. These are usually animals that migrate seasonally and have to know north and south. So these are animals like sea turtles and some kinds of fish, birds, monarch butterflies, even some kind of bacteria have this magnetic sense because they need to be able to orient themselves up and down in the mud that they live in. So these guys were like, yeah, it kind of sucks, that all of these other animals have this cool gear we don't.
Yeah, it's almost like a cross-species penis envy.
So when I was there, they had just finished building this device for their leader, Tim Cannon's arm. And this device is called Circadia. And it was about the size of a deck of cards. And it went on the inside plane of his left arm. And it was basically a temperature sensor. And it took his temperature and ported that information to his cell phone. So he could kind of check it and be like, oh, yeah, look, things look normal. And you charged it with a battery coil that you would hold up to his arm. And when he did that, it would light up. It looked really, really cool, like really, really cyborg, you know? And that, you might say, what does that have to do with sensory perception? Well, nothing. The reason they were doing that was basically to make sure that they could build an implant, that it would work, that they could recharge it, and that Tim wouldn't die. So those were their main concerns. Tim wore it for 3 months, and they took it out because they noticed that the battery was expanding due to the heat of the charging coil. So that was it. But when I was there, I went with them. The book opens with us going to Radio Shack on a Friday night.
Yeah.
Because they're buying parts to build the next thing they want to build, which is this idea of a compass you would implant in the back of your hand. They call this North Star. And the idea is the compass will light up when you're facing north. It's kind of like a workaround to not being a homing pigeon.
Yeah.
So they were just starting that process when I was there, which was the tail end of 2013. And they just came out with their first demo version of it this Thanksgiving. So North Star version 1 exists, but it doesn't have the compass element in it. It just lights up. But they managed to do it. They got it down to about the size of a quarter. I think 5 or 6 people have had it implanted so far. So they're on their way.
So when people are cutting open their arms, like, is this a doctor doing it, or is this just kind of people on their kitchen counter, hoping that nobody's the wiser?
Actually, for the most part, it's neither. It's usually body piercers. They go to like a professional body mod or body artist, because there are a lot of people who have worked on designing kind of silicone encased jewelry and that sort of thing, who do it for, people who are interested in body modding just for appearance. And they've started working together with people who are interested in body modding for function. So some of the other things that people get implanted, a really common one is to get a magnet implanted. And again, those are encased in silicone. It's not like somebody just jamming a magnet in their hand. And that's another bid to see if you can pick up some kind of electromagnetic sense or interaction with the world. I met quite a few people who had RFID chips implanted, usually in their hand. An RFID chip, is like I have one on my entry card to get into my office at work. I have one on my car so I can go over bridges, and it, records the toll that I owe. A lot of people chip their pets so that if your pet gets lost, a vet can scan your pet and figure out who your dog belongs to. So some people have these chips in their hands, and then they use them to do things like start their computer. I met a guy who uses it to start his motorcycle. A lot of people use it to get into their house. They put a reader on their door and they just hold their hand up. So these things, I should say, they're way more subtle. You might not know if somebody had one in their hand.
Yeah, it's interesting. There's all this talk about smart homes and the Internet of Things, but we're going to start having really smart bodies too at the same time.
Yeah, and it raises some interesting questions. Like I was asking these guys, aren't you worried about being tracked? Having an RFID chip in your hand seems like you're opening yourself up to some possibilities for surveillance. And they said, no, because we control these things and their range is really small. And if I'm the one installing the reader, then I know where that information is going. They were pointing out, you do things in your ordinary life that are way more invasive in terms of tracking and surveillance. If you're using that grocery club card, if you have, the toll pass on your car, your cell phone is tracking all kinds of information about your location and your activity. So they're like, this is nothing new. But I did talk to some critics who said, the next frontier kind of is chemical sensing, the idea that you have a sensor that's in your body that's recording what's going on biochemically. And they said the invasive possibilities for that are huge. And, a lot of people are really interested in recording what's going on inside their body for health reasons, for health optimization, right? They want to know about cholesterol or how many calories they burn, how far they've run, what their sleep is like. But some of these critics said to me, okay, imagine your employer makes you do it because there's a health insurance reason for it. Like they want to get a better discount rate on their health insurance. So now your employer is requiring you to track these health metrics. Or what if you had to use one of these for some kind of compliance with like a court order or with the medical regime assigned by your doctor? Imagine they're tracking what's in your blood chemistry because they want to know if you've taken an illegal drug or if you remember to take your meds. So that's a pretty eye-opening possibility.
Yeah, I think it's going to be hard to imagine a real dystopian future like that, at least like, in the US or Western Europe or some of these places where the idea that your body is sort of your own private temple is pretty built into the culture, unless you do something like you sign up for the military or you commit some felony that you sign away some of your rights in those cases. But I find it hard to think that we would change the laws so radically to allow the kind of things that we wouldn't allow a police to do illegal search and seizure now.
Yeah, the law so far has not really smiled upon this idea of tracking people with RFID chips. In fact, some states have laws against that say your employer can't require you to wear a chip to track you. But a lot of people I talked with said, you know what? It's not the law. It's social and economic pressure.
Yeah.
Social and economic pressure evolves way faster. And so they said, if there's an advantage to it, workplace advantage, I'll use evolutionary in quotes because I'm not talking about evolution over millennia, but I'm talking about
cultural evolution, not biological evolution.
Exactly. They said, yeah, people are going to do it. If there's some advantage to wearing smart glasses that help you do your job better, help you do better at school, people are going to wear them. And this really great scholar that I talked to, his name's Dr. Gregor Wolbring, and he's at the University of Calgary. He's a abilities and disabilities scholar who's really interesting to talk to because a lot of assistive technologies that have been developed, there's a lot of debate in the disabilities community about, are they welcome? Are they helpful? Do they kind of create these ideas of what a body should look like or what a person has to do to be considered productive or normal? So people are sometimes critical of these things. And he says, look, a generation ago, nobody had to use the internet. Nobody had to use a laptop. A couple generations ago, nobody had to use a phone. But now you have to know how to use all of these things if you want a middle-class job, if you want a college education. And he said, yeah, sure, you could opt out if you want, but there's going to be consequences to pay.
Yeah, it's like you could choose to be illiterate, but it's not a very good idea. I can't imagine hiring somebody now that didn't have an email address or that refused to have a cell phone. And, if I couldn't reach the person, I'd just be like, well, shucks. Same thing actually with just a regular phone. So like somebody could opt to not have a landline, but it's going to be pretty hard for them to participate in society.
Yeah, he said, if you want a job delivering pizzas, you have to know how to drive. So there are all of these expectations we have about technology and our abilities to use them. In fact, you just pointed out a great one, which is literacy. One of the arguments that I make in my book is, it's called We Have the Technology, but that doesn't just mean gadgets and things that light up and make noise. I make the argument that language is a technology. It's something that we developed to make our lives better, and it alters your perception. Chemistry, medicine, these are technologies, and they alter our perception, and they're tools. There's always going to be pressure to kind of keep up with the pack. And when I talk to some developers who are making smart glasses and other augmented reality devices, they said, that's just it. That's what we do. We're a tinkering maker species, and we have done this since the dawn of time. Since the first guy, figured out fire, everybody else has had to catch up or be left out, and that's just what we do.
And everything seems weird. If it's invented by the time you're over the age of 40, then you're not really comfortable with it, and it seems a little bit obnoxious. But like if it's there when you're 15 years old or younger.
Yeah, you're just used to it.
Yeah. Are there any of these bizarro bleeding edge technologies or ideas that you might be tempted to try yourself?
I was offered quite a few implants, but I'll tell you, I didn't get any. And I actually, I had thought of myself going in as a fairly unmodified person, but now I keep reevaluating that. I keep thinking about, what do I use in my daily life that is actually some kind of augment? Like, does taking vitamins, is that an augment? Yeah, maybe it seems like it. So yeah, I'm trying to think, what was there that I would use? Now, I should say a lot of the technologies that I wrote about are only available for clinical trial. Some of them are still only in the animal model stage of development. They're not for sale yet to people. So there's some of them I couldn't get. Like I couldn't get a retinal implant because you have to have pretty severe vision impairment for that retinal implant to help you out.
Right.
Same thing with neuroprosthetics, right? Like you have to have either a stroke, ALS, something that prevents you from moving, or an amputation, something where you need a limb. That said, so I observed a really interesting program in a French hospital where a group of really sweet women who I don't think would consider themselves biohackers were doing a thing that I thought was pretty cutting edge, was pretty clever. These are all women who have worked in the cosmetics industry. And what I didn't know when I started researching this book, and was really surprised to find out, is that problems with sense of smell are the first clinically diagnosable symptom of Alzheimer's. They're also a very early symptom of Parkinson's disease. And that has to do with the really intimate connection between smell and memory.
Yeah.
So smell is probably the first sense that animal life evolved. And because of that, in the human brain, the olfactory center of the brain is only a few synapses away from the centers for emotion and memory, which is why smell is so emotionally evocative. Alzheimer's is very complicated. It's not quite fully understood. But one of the things that happens very early on, it's not that people can't smell at all. And it's not that they can't derive pleasure from a sense of smell. It's that they have trouble differentiating between different smells. So they've tested this in people and in mice. And as Alzheimer's progresses, people have trouble telling the difference between, say, two floral scents or two minty scents. And over time, things start to smell all alike. And this can make a big difference in quality of life because smell and taste are very closely connected. You've probably had that experience when you had a cold where you couldn't taste food. and life was really horrible. So they kind of work together for this perception of flavor. So it can mean that eating is very dull and you lose a lot of the pleasure of life. Another thing that is happening to people who have very advanced Alzheimer's is often they withdraw socially because they have a hard time communicating. They can't remember people's names. They can't remember words. So they kind of withdraw into themselves. And the women who run this program, the group is called Cosmetic Executive Women. They had been doing this program where they'd created what they called a library, a bibliothèque of scents that they would bring into the hospital, and they would dip a paper wand into these little vials of the scent, and they would wave it under a person's nose, and they would say, "What do you remember?" And they found that this was a way of kind of drawing people out of their shell. And sometimes they were just trying to get people to kind of say, "Oh, that is," on the day I was there, they were doing fruits. So it was like, "Oh, that's blackberry. Oh, that's apple." But sometimes people would actually have a memory, and they were telling me all of these stories of people who suddenly kind of burst out with a little story, a little anecdote, and were very kind of emotional and vibrant. And then moments later, we're kind of gone again. And they said, this is a valuable thing for the families and friends of people who have these neurodegenerative disorders, because it shows them that the person that they love is still there. It kind of gives that person a moment of relief and connection. It helps them talk to other people, and it reminds the family that your grandfather, your husband, the person that you love is still himself. And this is a way to draw it out. And so some of the people I talked to said, you could do this at home. If there's somebody in your family who has a memory disorder, you could get some old perfume bottles. You could get some old clothing out of the attic. Anything, or you could cook a recipe that's beloved. Anything that might kind of stimulate that memory for somebody might help. I thought that was kind of neat.
Yeah. You don't think of that as being like a brain hack, but I guess it really kind of is in the low-tech sense.
Yeah. The original sense of it, I think of a hack as being kind of a clever trick to fix a problem, right? And of course, it doesn't cure anything, right? It's fleeting. But it is kind of a clever way to say, okay, we're going to circumvent the part of the system that's having the problem, which is smell identification. And we're going to go straight to the part of the system that is still working, which is the connection between the smell and this memory. And one of the things that's really neat about it is it can work even if the person can't correctly identify the thing they're smelling. So there's another group doing a project like this in Singapore, and they told me this cool story about giving a man who had grown up in India the scent of jasmine, which they thought would be a good memory for him because it's kind of a beloved flower in India. And he said, "Oh, it's roses." And it wasn't, right? He got it wrong. Yeah. But they said, "What do you remember about roses?" And he said, "Girlfriends." And they said, "What do you remember about girlfriends?" And he told them the story about, as a teenager, how the boys at his all-boys school would buy flowers to give to the girls at the convent school across the street. Well, he got the smell wrong. The connection was wrong, probably because of this neurodegeneration that he was having. But the outcome, which is that he was able to talk to people and recall this memory that gave him pleasure, that worked.
Yeah, absolutely. I'm wondering if this is something that you looked at at all. I'm thinking about the Paralympics and some of these things where you see somebody that might be missing a leg but is still running amazingly. And the technologies there seem to just be getting better and better and better with physical prostheses. And we talk about the Moore's law of computers getting twice as fast and twice as cheap every 18 months. And I imagine there's some level of that bleeds into the prosthetics world. Do you have any gut instinct on when it is that some of these physical alterations that people are able to get now in the case of disability or injury might be honestly better than what our built-in hardware is, where somebody might, I'm just going to get my leg amputated because I want one of those nifty new prosthetic legs?
Yeah, that's an interesting question. Well, okay, I'll give you an example where maybe in some ways it's already here. But in terms of, voluntarily getting an amputation and a robotic limb, I talked to a bunch of people who said, heck, I would do that if I could, but no doctor's going to give it to you, no insurance.
Yeah, the Hippocratic Oath has something to say about that.
Right, exactly. Do no harm, right? And a lot of people said, look, why even bother with that? Why not get something wearable, like an exoskeleton you can take on or off, or some cool augmented or virtual reality goggles that you can take on and off? You don't even have to mess with surgery and infection and getting things upgraded every few years. You can just get a new gadget. But I'll tell you a really cool thing that kind of blew my mind. I have one of my chapters is on the first retinal implant. And I met a man who's actually wearing one today. He was a clinical trial participant. This man, his name is Dean Lloyd, and he had been born with vision. He lost it as an adult thanks to this disease called retinitis pigmentosa. So it kind of destroys the photoreceptors in the back of the eye, in the retina. And he had been essentially blind for 17 years. And then he volunteered to be a member of this clinical trial for this device called the Argus 2. It's made by this company called Second Sight. So this is actually a chip that's in his eye. And the way it works is he wears a set of glasses that have a camera mounted over the bridge of his nose. That camera takes visual images from the video and converts it to electric impulses that are fed to the chip in his eye. That chip in his eye stimulates his surviving photoreceptors at the back of his eye, and that information travels up his optic nerve and is translated by his brain, kind of the way it would work with anybody else, right? Now, the vision he gets is not the vision he remembers from before. He doesn't see three-dimensional objects. It's very low resolution vision. It's kind of like 52 pixel vision because that chip in his eye only has 52 working electrodes.
It's like he's looking at Q*bert from 1984 or something like that.
It's not even that fancy. And the problem is the lights kind of don't light up in the right order. So what he mostly gets, he described his vision to me as boundaries and borders. What he means is these flashes that he gets where a dark area meets a light area, so high contrast points. So he gets it like we were walking down the street and he was saying, okay, I see all of these flashes where the white of the sidewalk meets the black of the asphalt. And when he was looking at me, I'm just biological material. There's not a lot of high contrast points on me. And he was saying, oh, your eyes are glowing. And I said, what does that mean? And he said, oh, it's your glasses, right? All he could see of me was the reflection of my glasses.
Yeah.
But that said, it's enough information that he can kind of get around. He can tell when people are close to him. He can look at objects on his desk or the kitchen table and figure out what's what. But here's like the cool thing where Dean Lloyd's vision in some way might be better than ours, right? So I was asking one of the people at the company that makes this device, hey, does Dean's camera have to be hooked up to a regular camera? And they said, no, we could hook it up to like a night vision infrared thermal camera. And, conceivably, he could see better at night than you and I can, right?
Yeah.
They said there's no reason his camera has to be something he's wearing on his face. What if his camera was connected to your computer? So he's seeing out of your computer. What if his camera is hooked up to a camera on the other side of the world? What if that camera is in like Moscow or Tokyo or Nairobi? He could have true television, the ability to see at a great distance. I was saying, does this camera record? Like, can he play back things and get instant total replay?
Oh, instant replay, right.
Yeah. And they said, no, but that's interesting, right? So that was cool. And then he does have, actually now in the current version of the device, he has some powers that you and I don't have. So one of the things that he can do is he can press a button and his camera will invert white and black. And the idea is it's to help him figure out where doors and windows are, makes them easier to see. But he can do this flip. He can also make his world more high contrast, which is meant to help him figure out like walls and corners, right? All of these angles. So he can do kind of cool things with his eye that we can't.
The human eye has like this amazing iris that you step out in a bright day and at first it seems really bright and your eyes quickly adjust, but it would be interesting to have some sort of manual control on.
Yeah, actually there's a group at University of UC San Diego that built a zoom contact lens. So you can zoom with your contact lens. That's pretty cool, right? So some of these are happening. But yeah, the day when you can go in and, Tim Cannon from the Grindhouse was saying, I can't wait for a day when you can just walk into any storefront and say, give me a Circadia and give me a Bionic eye, and they'll just do it. And that day, I think, is still a while coming.
So sort of last question here, but this might be a big one because it kind of gets into meaty philosophical territory. But you made the point a couple of times in this conversation that a lot of this stuff, like the wearables, seem like a great way to go. I don't always need a bionic exoskeleton that lets me lift a bulldozer, but every now and then it would be handy. But there are some of these technologies that I feel like we kind of would want them to be a part of us because it has to do with our sense of identity. Like sex is actually a great example. It's like I would rather have my own body be sexually attractive to my mate than just like put on my robot sex costume and which the next guy could buy for $99.99 too. And it doesn't really distinguish me. It doesn't help my identity just to have a wearable gadget for that. Where do you see some of like the boundaries of when it's useful to have something which affects a person's identity rather than is just sort of a costume or a gadget?
Oh, that's an interesting question. Let me think. Well, for my own body, I think there are augments that I've accepted because I think this is good for my health, right? Like vaccination is very easily one of those. Jesse, let me make sure I understand the question. So you're saying like,
I don't even know if I understand the question.
when would you want to have it like incorporated into your body versus when would you want it to be removed?
Not even necessarily you, but like where do you think society might opt for something that's sort of an internalized gadget rather than a wearable?
Okay. Really interesting questions that came up on that point over and over as I was talking to people is, okay, this idea that we've always kind of hacked our sensory perception throughout human history in a lot of ways. We've done it with things like language and culture that kind of affect what you learn to pay attention to. And then, of course, we have all of these other devices like eyeglasses, ordinary devices that give you some kind of sensory power that don't seem to be like a big deal at all. When it comes to things like virtual reality, augmented reality, this idea of using some kind of device to transport yourself, to live an alternate life, to inhabit an alternate body. A lot of people who work in those worlds would say, yeah, people have always done this since, storytelling, the invention of books, the invention of radio, cinema. People just love to, inhabit alternate lives and live ways you ordinarily could not. That's no big deal. So putting on virtual reality goggles or augmented reality smart glasses or whatever, it's not any different than what we've been doing all along. But the big thing that seems to really make a difference to people is the idea of what if this technology gets so good, so subtle, so pervasive that you don't know when it's on and it's off.
Right.
You no longer know kind of when you're in the dream. Because at least with a movie, you walk out into the daylight with a book, you close it, you put it down. Even with VR glasses, they're not subtle. You take them off. But what if we get to the point where the thing is actually implanted in your body, perhaps eventually implanted in the brain, or it's some kind of biochemical sensor that is very slowly altering what's going on in your body, and you kind of don't know when the dream begins or ends. One of the new technologies that I talk about some in my book is this idea called optogenetics, which means controlling neural cells with light, with implanted fiber optics. And it's a very, very precise technology. And a lot of people have said, okay, this kind of level and precision and control gets us to the point where you can actually start to reasonably think about brain implants being not too far off. And at that point, might it be possible to actually be stimulating neural cells in such a way where the person is no longer even thinking about the fact that they're wearing a device? It just seems to be a new reality to them.
Yeah. It gets real spooky when you start thinking in those ways because everything that we perceive is ultimately, it's brain signals getting perceived. I see the rock across the room from me, but it's the light hitting my retina and getting processed like, oh, there must be a rock there. And if some other signal was triggered in the same way, the rock need not be there. Augmented reality will be really interesting when it gets pixel realistic fidelity that sort of matches what our eyesight can give us naturally.
Right. And this is kind of a sci-fi nightmare that, has been repeated over and over. This is the whole idea of the Matrix and stuff like that, of people being involuntarily plugged into a machine, dreaming for them, right? Causing them to have this life that they don't really have. And you could argue that in some ways the brain already creates a lot of false experiences for us. Like this happens to you every night when you go to sleep and you dream. You have this whole other set of experiences that are basically just this electrochemical storm that's happening in your brain. And you daydream all the time. And of course, humans have this long history of psychedelic drug experimentation. But of course, like with these examples, the trip ends, you come down from it, you wake up. The question is, could we be in a perpetual dream?
Yeah, I guess the other thing is in those naturally occurring situations, it's either random or at least not under anybody's control. When we're talking about mixing technology with these perceptual implants, presumably like, if Google turns evil and decides to put you in the Google shopping dream or the Amazon shopping dream.
It's just like ads all night.
Right, exactly. Who knows?
To be honest, raises another big concern that a lot of people brought up, which is like if you're wearing a device, whether it's implantable or if you can take it off, a lot of information is being collected about you. And where does that information go? And how is that information going to be used? And could that information be leaked or breached, right? So a lot of the biohackers, when I would ask them about this, said, look, the solution to everything is make it open source, because that way you build your own gadget, you know what it does, you know what's in it, you know where the information goes, and you can control the price. No corporation can have a monopoly. But the obvious counter to that is like, maybe I don't want to do that. Maybe I don't want to be in the basement building my own smart glasses. Maybe I'm not good at that. So there are a lot of people who are going to be probably buying these next generation devices who are not going to be aware of what it can do and what its limits are and where their information might go.
Smart Drug Smarts.
So thank you so very much to Cara Platoni for taking the time for that conversation. The book is We Have the Technology. I'm about 2/3 done with it now, but unless it turns into a stinker in the last third of the book, which I very much doubt, I can definitely enthusiastically recommend it. It's a very upbeat, future positive sort of book. The cover has one of these 1950s guys like out of an Archie's comic, just, beaming in joy. And as you could tell from that conversation that we just had, I think that's fair to say that Cara's take on the near future is a fairly positive one. Personally, as somebody that's always been a fan of colored glasses, like I've loved the rose-colored glasses that you put on and make everything look like you're in a Tangerine Dream video. And I think some of the augmented reality technologies that are going to be coming down the pike in the next couple of years, just the ability to walk down the street and be looking at everything in black and white and dial up the contrast and pretend that you're in like a 1940s detective movie, that's going to be so darn cool. Just to be able to live your life in something like an Instagram filter over your own reality. Things like that are purely cosmetic. They're not necessarily going to be revolutionary or change the way that we live once the novelty wears off, but it sure does sound cool now. I'm super excited about that kind of stuff. But of course, the technologies that actually extend our capacities or extend our lifespan, that's where the real rubber hits the road. And in fact, that's a great lead-in to the ruthless listener retention gimmick.
Smart Drug Smarts, ruthless listener retention gimmick.
So in that conversation that we just had, we talked about some of these technologies which are sort of biohacking that have been around forever, that we're completely comfortable with, things like eyeglasses and contact lenses and ear piercing and makeup. And, it may be that we were a little bit dismissive of it just because these things are so familiar to us. And it's easy to say, oh, well, biohacking is just more stuff like that. And then all of a sudden you come across a study or an announcement like the one that's been recently published by a research team at the Wake Forest Baptist Medical Center in Winston-Salem, North Carolina, and you kind of gulp and say, wow, maybe we really are crossing to a whole new threshold here. This team has recently announced their work on something that they call the ITOP, the Integrated Tissue and Organ Printing System, which is using 3D printers to print human organs that have a variety of cell and tissue types. So it's not like one big, solid, undifferentiated chunk of meat, but they've actually been able to do it with complex tissues. In this case, most recently, a human ear, or I should say a human-esque ear, something which has similar tissues and looks like a human ear about the size of a baby's ear. They did this with 3D printing combining a biodegradable plastic-like material and a water-based gel. The plastic forms the shape of the 3D structure, and then the gel contains tissue cells and encourages them to grow. When this semi-living printed object is implanted in a living thing, in this case they took this baby-sized human ear and they actually put it underneath the skin of a mouse. Not because that's any reasonable place to put it, but just because mice are cheap and readily available and they wanted to see if it would survive as a transplant. And within 2 months after the transplantation, the ear structures, they maintained their shape, still looking like human ears. How they did this under the skin, I'm not exactly sure, but they'd formed both cartilage tissue and a system of blood vessels. So essentially it was integrated into the mouse's body and became a living organ structure. Not satisfied with just ears, the researchers also used the ITOP system and human stem cells to build jawbone fragments, which the team notes were of a size and shape big enough to be useful in human facial reconstruction if somebody had an accident or something like that. And although in that case it took a little bit longer, it took 5 months, but the bone fragments also formed blood vessels when implanted in rats. They've also constructed muscle tissues, and those tissues, after being implanted, were infiltrated with blood vessels and triggered nerve formation in only 2 weeks. Dr. Anthony Atala, the senior author of the study, explained how the ITOP technology might be used. We'd bring in the patient, do the imaging, and then we'd take the imaging data and transfer it through our software to drive the printer to create a piece of jawbone that would precisely fit in the patient. This tissue and organ printer is an important advance in our quest to make customized replacement tissue for patients. It can fabricate stable human-scale tissue of any shape. So this is clearly incredibly cool, but also makes you think of all the weird possibilities that are going to be opened up by this. I think back to a movie like Island of Dr. Moreau, and I think of my weird friends and how they might deck out their houses for Halloween in the future. Imagine being able to print a 6-foot-tall human body, but was essentially a house plant. You didn't give it a brain, you just printed some human-like skin on the outside of a mannequin and watered it with a circulatory system or something like that. That seems like it's not far off from being a feasible thing to do, but how freaky would that be if you could make a wax museum of things that looked like humans, weren't humans, they didn't have any organs or brains or anything like that, but had completely realistic human flesh on the outside. That's just freaky to think about.
Smart Drug Smarts, where we turn information into sound, into bits, into packet data that turns back into bits and sound, and then into neurotransmitters that release funds that release mail-order synthetic chemicals that cross the blood-brain barrier to release augmented performance from your brain.
Okay, you heard it. That is all for episode number 117. Thank you for hanging around until the end. And if you liked what you heard, I will humbly request that you spread the word about Smart Drug Smarts to a couple of people in your social circles. My long-held plans to hijack the Goodyear blimp and spray paint Smart Drug Smarts on the side and drive it all around have gotten continually backburnered. So in the meantime, positive word of mouth and social media and things like that are hugely appreciated, and let more people know about the show. This week's episode, as you know, will be at smartdrugsmarts.com/117 with links to all the stuff that we talked about here. Last week's episode was our psilocybin episode, the magical ingredient within magic mushrooms, and a chemical finally getting to see the light of day in research studies, hoping to tease out some of the medical applications for which it might be useful. We got a lot of positive feedback about that one, and it is not at all inconceivable that there will be another psilocybin episode in the future. Getting a little bit more frisky with the topic, looking at it from a less medicinal and more recreational use standpoint. I told you last week that this episode was going to be on something called Captagon, and obviously I lied because that's not what this episode was about. But it just goes to show that we like to play fast and loose here at Smart Drug Smarts. I'm not exactly sure what next week's episode is going to be either, but if you held me down and made me place a bet on something, I would say it's going to be turmeric. But that is not my final answer. There's also a small chance that we might be doing a special Leap Day episode in a couple of days here. It's Leap Day on February the 29th. It only comes around once every 4 years, so you got to take advantage of these things while you can. So we may slide a little overdose edition in between this week and next to celebrate Leap Day. But as for episode number 118, that'll be on schedule as usual next Friday. Same time, same podcast, same host. So have a great week. Maybe see you in the middle. And as usual, stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.